circumference and area of circles. And that's all we're really going to talk about, circumference and area of circles. So first of all, the question up there is, what is pi? Unfortunately, we couldn't do this on Thursday because Thursday is pi day. And pi is 3.14. Let's go to black. 3.145. Ew. Too early. So on and so forth and so on and so forth. If you want to see all the digits, well, you can't see all the digits because it goes on forever. You can turn around my pi and then memorize all those for half a point extra credit.
140. Wouldn't that round up though? No.
I'm going to run it down to 0. But if you take the time to memorize all these, then you get half point extra credit. But anyway.
I'm confused.
What are you confused with?
Huh?
What? Okay, what is pi though? I know we know the number, but what is it? Where does it come from? Well, pi is actually just the ratio of the circumference to the diameter. Does anyone remember what a circumference of a circle is? Life?
2 pi r.
I'm asking, what is it though?
It's like around the circle.
Around the circle. It's the distance around the circle. So your circumference is the distance around the circle. And what's that diameter? It's a length from one end of the circle to the other end of the circle. So a circumference. When I'm talking about circumference, I'm talking about this distance here, all the way around. What is that distance? That is your circumference. Circumference is that distance. Now, if I draw a line that goes through the center of a circle, we draw a line through here, I am now drawing a diameter. That whole thing is my diameter. And half it will be our radius. So we have a diameter, we have a radius, and we have a circumference. Lyth was actually 100% correct. Yeah, sorry. Ethan.
The diameter has to go through the center point.
It has to go through the center point, otherwise it's just a chord. A diameter is a very special chord that goes to the center. It is the longest. So the point of it going through the center is it is the longest distance across the circle. Because anything above this line would be a shorter line. Anything below it would be a shorter line. But we can rotate it, right? All right, but Lyth was 100% correct with his circumference. He said circumference was, what did you say again? 2 pi r. Circumference equals 2 pi r. Now we can talk about circumference in terms of diameter. Does anyone take a shot at how I'd write circumference if I just wanted to talk about the diameter? Yeah. Oh.
Wait, no. Pi.
Yeah.
1/2 in diameter.
Be careful,
2.
because what does 2r equal? What distance would I have if I had 2 radii?
1 whole diameter.
1 whole diameter. So if this already has 2r in it,
Oh, then pi r.
not pi r, yeah, like
Pi diameter.
pi times diameter. It would just be pi times d. And that is because, pull a note off to the side, well, d equals 2r. 2 radii becomes your diameter. So circumference is either 2 pi r is what we most often say, but if you just know the diameter, you can just say, well, it's pi times diameter. Or you could take the time and find your radius and then go 2 pi r. All right, area of a circle with radius r, yeah. Say that again? Pi r squared, yeah. Area equals pi r squared. All right, our most important ones are the 2 pi r and the pi r squared. Now, really quick, we can know the 2 pi r, we can know the pi r squared, but we're just going to have a little flow chart depending on what you know. So when we're doing our circumference, let's say I just know the radius. We're going to go with our circumference, and the formula is just 2 pi r. If I know the diameter, I can just go, well, it's pi times diameter. For area, if I know the radius, we're going to use the pi r squared. If I know diameter, this one's used kind of a lot less. It would just be pi times, well, radius is diameter divided by 2, so it'd be pi times diameter divided by 2 squared. For my money, I always just remember the 2 pi r and the pi r squared. You can always find r if you know the diameter, you just divide it by 2. All right, so that's area and circumference of a circle. Now a little bit further, we got an example. What is the area and circumference of a circle with radius 10? Let's do our circumference first. Our circumference is 2 pi r. In this case, our radius is 10, so it'd be 2 pi times 10, which is just going to equal 20 pi. Our area is pi r squared. Well, it says that our radius is 10. Let's get a better equal sign in there. So we're just going to have pi times 10 squared. Well, 10 squared is 100, so that's going to be 100 pi. Circumference 20 pi, area 100 pi. Our next one says, what is the diameter of a circle with circumference 16 pi? What is the diameter of a circle with circumference 16 pi? What can I do for this one? Ethan? Do the pi times diameter. Yeah. Circumference equals either 2 pi r or it's pi times diameter. So we know the circumference is 16 pi. That means that has to equal pi times diameter. The good thing is you would divide pi on both sides. So your pi's would cancel out. Divide by pi, and we don't have to worry about pi anymore. And we're just going to be left with 16 equals our diameter. Now, real quick, I'm going to do something on the other side. I'm going to use the fact that circumference equals 2 pi r and see that we can get the exact same answer out. So if circumference is 16 pi equals 2 pi r, I would divide both sides by 2 pi. Divide that side by 2 pi. Divide this side by 2 pi. That's going to leave me with my radius equals 8. You multiply that by 2, and you'd get your diameter equals 16 as well. So if you just remember 2 pi r, it all still works out. But if you remember pi times diameter equals our circumference, that's also a nice little shortcut. All right, next one, we're really focusing on the arc length, but we're also going to talk about the area. We'll talk more about the area in later lessons. But we're talking about finding areas and arc lengths of specific sections of a circle. Now, when I talk about arc length, I'm basically talking about circumference cut. So it's like we can calculate the circumference of an entire circle, but I kind of want the circumference of just this little section? Well, we call that arc length. Arc length is basically the circumference of just part of a circle. That's what arc length is. So when I'm talking about arc length, I just want this little top part that's connected to that pink section. So the important part of finding that pink section is how much of the circle is that pink section connected to. So the key there is, what is the degree measure of this? Well, this central angle is 90 degrees, so what's the measure of the arc? If our central angle is 90 degrees, what is the measure of the arc? Tyler? It's a fourth of the circle, but what degree measure is this? If my central angle is 90, it's going to be 90 degrees. So our arc measure is 90 degrees. And I absolutely agree that that's going to turn into a quarter of the circle. But that's pretty easy to see just how it is. So knowing it's 90 degrees, how we're going to figure out how much of the circle is every time what we're going to do is we're going to do, how many degrees are total in a circle? 360. So we're just going to go 90 degrees divided by 360 equals 1/4. Or in other words, the percent of how much circle we're talking about is your degree of your arc divided by 360. That is how much percent of the circle we're talking about. So I'm dealing with a quarter of the circle. I'm dealing with a quarter of the circle. So let's just start with, what was I starting with? Total. Let's go total. Our total circle. So let's talk about the circumference of the total circle. The circumference of the total circle would be 2 pi times the radius of 10. So our total circle would be 20 pi for circumference. For area, we're going to have pi r squared, so that's pi times 10 squared, which equals 100 pi. So if I'd ask for the total circumference or the total areas, that's exactly what you're going to give me. You're going to give me 20 pi, 100 pi. I didn't ask for the total. I asked you for that shaded region. It says find the area and circumference of the shaded region. So to do our shaded region, we're going to take a percent of that 20 pi and a percent of that 100 pi. And we said that's a quarter of our circle. So the shaded area is going to be a quarter of your area, and it's going to be a quarter of your circumference. So to calculate a shaded section, I just need to calculate the circumference and the area and multiply it by the percent of the circle we're talking about. So this shaded area is going to be, let's do circumference first. It's going to be 1/4, that says 1/2. It's going to be 1/4 of that 20 pi. Well, a quarter of 20 pi is going to be 5 pi. Our area will also be a quarter of our total area, which in this case was 100 pi. A quarter of 100 pi is going to be 25 pi. So that's where this formula came from. This is arc of an unbroken part of the circle. The arc of an unbroken part of a circle, remember that is basically circumference of part of your circle. It's going to equal, well, the length is our circumference. So this is our circumference formula times how much percent of the circle I'm talking about. So we first calculate our circumference, and then we multiply it by 1/4, or multiply it by whatever fraction we come up with, and that is what degree measure is that arc divided by 360. That'll give me the percent of the circle that we're talking about. So that 2 pi r, that is our circumference. And that x divided by 360 is just the percent of the circle. How much of the circle are we talking about? And that's all we need. The quicker you understand this, the easier these parts are going to be. So just understand that all I'm doing when I say arc length is I'm asking you to calculate the circumference and multiply by how much of the circle we are taking up. All right, let's do some examples. All right, the first one says, in circle A, inscribed angle BCD is 36 degrees. If the radius is 24 centimeters, what is the length of arc BC? So let's first draw a picture to see what's going on here. So we have an inscribed angle. We have an inscribed angle BCD, so B must be on the circle, C must be my vertex, D must be here, and it says it's 36 degrees. Now, I said from this past one, we need to know that degree measure of the arc. We need to have that degree measure of the arc. So what's the degree measure from B to, what is the length of BC? Is that the one I wanted? I feel like I wanted to find the arc of BD. I didn't think I wanted to make that big of a leap. Yeah, we're just going to find the arc length of BD. Let's not make this more complicated in class. So we're going to find the arc length of BD. We're going to change that to BD. All right, what is the degree measure from B to D? Like,
72.
it is 72 degrees. Remember, an inscribed angle is half the measure of the arc it's subtends. So once again, we're switching this to BD. I don't want to make it more complicated than it needs to be. All right, it says the radius is 24 centimeters. Now remember, our arc length is going to equal our circumference, which is 2 pi r, times our percent. So our x over 360 times 2 pi r. Well, we have that x degree. That is that 72 degrees divided by 360. My circumference would be 2 pi r, which is, my r is 24 centimeters. And now we'd probably just take our calculator, go 2 times 24, multiply that by 7 over 360, and you should get out 9.6 pi centimeters. Don't forget about the pi. A lot of times you're just going to plug those numbers in your calculator and you'll completely forget, and you'll say it's 9.6 centimeters, and you'll use points on the test. So don't forget about pi. When I'm talking about circle, almost all your answers are going to have pi's in them. All right, next one says in circle G, measure of JR equals 108, and the length of JR is 9 pi centimeters. What is the radius? What is the radius? So let's draw this picture of what's going on here. So we have 2 points, JR. And we have JR is 108 degrees. That's the degree measure between the two. It also says the length of JR is 9 pi centimeters. So we also know it's 9 pi centimeters. Well, just remember your formula. Arc length equals our degree over 360 times 2 pi r. Well, in this case, I know the arc length. The arc length is 9 pi. I also know that 108 divided by 360 times 2 pi r. And now it's just solving for this. So what I would do is I would take 108 divided by 360 and multiply it by 2 in my calculator, and it's going to come out to a decimal. So we're going to have 9 pi is going to equal, I got out 0.6 pi r. I do appreciate people that are plugging this in their calculators to make sure you're practicing. That is awesome. And then what I would do is I would divide both sides by 0.6 pi and 0.6 pi. Now I would not throw 9 pi and divide by 0.6 pi. Instead, I would notice that my pi's would all cancel out. My pi over pi would cancel out. And then all I have to do in my calculator is do 9 divided by 0.6. And you should come up with your R equaling 15 centimeters if I did all of my math correct. I do not believe this is the hardest formula to memorize because you already know 2 pi r. At least most of you already know 2 pi r. So anytime I'm talking about a section of the circle, you just got to ask yourself, well, how much of the circle is that? Well, that's something divided by 360. That is your degree divided by 360. Good practice for several of you. I did notice on the test, several of you are not strong at just filling in information from a formula. Like you kind of get lost along the way. So if you kind of feel like you're one of those people that kind of get lost along the way, make sure you write it every time and fill in the information you are missing. Don't just try to, in your head, just memorize what needs to go where. Write it out and fill in what information you know. All right, questions on anything we covered today? All right, so number 13 says, what is the measure of the angle formed by the hands of the clock at 10:20? Everything else after that is a hint on how to solve it. First of all, it is not 180 degrees. And why it's not 180 degrees, so if we look at 10:20, your small hand's at 10, and your big hand's at the 20, so it kind of looks like, hypothetically, it should be 180 degrees. However, what does your hour hand do as the minutes tick by? It moves. Look at the clock right now. It is 7. It's not 7. I need to change this. But it's saying that it's 7:37 or something. But no, my hour hand is not pointed right at the 6. So the hour hand consistently moves. So the hint in that one is, how far did it move in 20 minutes? Because it's not pointed right at the 10, it moved part of the way. So 13 is going to be a difficult problem. 14, you need to draw a complete circle around the information they're talking about. I did write down how I did both of these. Try your best to understand what I did, so when you come with questions tomorrow, you can be like, I don't understand why you did this one specific thing, not just I don't get the whole problem. All right? So try your best to look at the answer guide if you get completely stuck, and use that to come up with questions about why I did specific things. All right, guys, the rest of the time is yours.